Hi guys, welcome to the next video. This should be a short and sweet one. This is the force between two parallel wires. So last video we learned all about the right hand motor rule and how to apply that. Now we're going to look at two parallel wires. Now these are current carrying wires, and so when we have two current carrying wires, if they're placed close to each other, the magnetic fields will interact just the same as any other magnetic fields would interact. So it's no different to two bar magnets being close to each other. And so we get some consistent things, however, and you just need to remember this. So if the wires are in the same direction, so in this case they're both coming out of the page, so they both got anti-clockwise fields around, these fields coalesce into this shape, and you can see that no field lines are going into here. So the net result is that these two wires will, if these are the two wires, they'll swing together. They'll experience a force together. Now if the wires are in opposite directions, you can see that one here is clockwise, one's anti-clockwise. You get all the field lines packing into this area here, and the result is the wires will experience a force in opposite directions. So you just need to remember that. What do you need to remember? If two wires each carrying currents in the same direction, the force is attractive, and if the two wires carrying currents in opposite directions, the force is repulsive. That was pretty sweet, hey? And these are just some diagrams that people have drawn up in computer graphics to show the same thing. Now the formula that we would use to describe this force is this one here, which is on your information sheet. Again, force magnetic, so that will be in newtons. This is our constant, but it's our magnetics constant. Okay, I, we should start to be on the ball now and recognize that I is the current in one of the wires, I is the current in the second wire, and it's in amps. We have the distance between the two wires, and then the length of the wire that we're actually talking about. So this is the length of the wire that we're actually looking at the force. Usually we just say 1 meter because that's our unit length, and so if that's 1, we get a force per meter, which is okay as well. So now you should be able to attempt question 25 in your booklet. Now this is a good time, because it's a nice short video, just to define the amp for you, or the ampere. And the amp is, what's the definition of an amp? Alright, where the current which, when flowing through two infinitely long parallel straight thin wires. So it's what we've just been talking about, two current carrying wires. If those two wires are placed 1 meter apart in a vacuum, we would get a force of 2 times by 10 to the minus 7 newtons on each meter of the wire. That's a pretty way out there definition of an amp, but that's how it's defined, and that relates to the force between two current carrying wires. So the next video we're going to now apply some of that force on current carrying wires, and we're going to look at electric motors and how they work and how an application of that. So cheerio again.